Welcome to the third lecture series of Quantum World.
In this lecture, we will talk about the origin and nature of electromagnetic waves. What do you think? What is wave? Wave is the physical phenomenon characterized by its frequency, wavelength, and amplitude. If we drop a stone into the lake, the stone will transfer its kinetic energy to the water. Wave that spread out from the point of impact carries both momentum and energy from one place to another place. Now, what do you think? What these waves are? These are mechanical waves need medium to travel. In this case, water is the medium for these waves to travel. What do you think? Do every wave need medium to travel? No, there are kind of waves known as electromagnetic waves, which don't need any material medium to travel. Electromagnetic waves are created as a result of oscillation between electric and magnetic field. If we consider electron as a moving charged particle, which will produce oscillating electric field. This oscillating electric field will in turn produce oscillating coupled magnetic field. These coupled electric and magnetic field components are perpendicular to each other and to the direction of motion. Both these coupled components travel as electromagnetic wave in the forward direction. These electromagnetic wave can be represented by Lorentz force equation. It is as correct to consider the moving electron as a wave as it is interpreted as a particle. We regard the electromagnetic wave as a wave because under suitable circumstances they exhibit diffraction, interference, and polarization. In other circumstances, electromagnetic waves behave as consist of beam of particle like blackbody radiation, photoelectric effect, and Compton effect. At this point, Maxwell was able to show that the speed c of electromagnetic wave in a free space, which is given by c is equal to 1 by epsilon naught mu naught under root, where epsilon naught is the electric permittivity of space and mu naught is the magnetic permeability. By putting the value of permittivity and permeability in the formula, he calculated the speed of electromagnetic waves, which is equal to 2.998 into 10 to the raised power 8 meter per second. This is the same as the speed of light waves. Correspondence was too great to be accidental, and Maxwell concluded that light consists of electromagnetic waves. In 1888, the German physicist Heinrich Hertz experimentally proved the existence of Maxwell electromagnetic waves. Hertz generated the electromagnetic waves by applying an alternating current to an air gap between two metal balls. The width of the gap was so adjusted that each time when current reaches its peak value, it produces spark within the gap. There was another loop which was the receiving loop or detector. Electromagnetic wave set up oscillation in the loop that produced spark in the gap. Hertz determined the wavelength and speed of waves he generated and showed that they have both electric and magnetic component, and found that they can be reflected, diffracted, and refracted. Light, which consists of electromagnetic waves, the eye responds to the specific frequency range, which correspond to the visible light spectrum. Visible light spectrum varies from 400 to 484 terahertz frequency range, which is for red light, to the 668 to 789 terahertz for ultraviolet light. Each light color has its corresponding wavelength. Wavelength for the red light varies from 620 to 750 nanometer to ultraviolet light, whose wavelength varies from 380 to 450 nanometer. Whole electromagnetic wave spectrum range from low frequency used in radio communication to the high frequency found in X-rays and gamma rays. Now coming towards conclusion, we can conclude that number 1, Maxwell tells us that what kind of waves they are. Definitely these are electromagnetic waves. Secondly, Hertz experimentally proved the existence of electromagnetic waves.
For viewing more informative videos, watch and subscribe our channel Quantum Words.